A vector of length L is turned through the angle theta about its tail. What is the change in position vector of its head? Here we have to see a vector which is rotating about its tail. Suppose a vector is drawn like this. It is representing a vector, and this is the head of the vector, and this point will represent the tail of the vector. Now in the question it is saying if this vector is rotated about its tail, suppose it is rotated about this tail in anti-clockwise, and it will appear like this after rotating at an angle theta. So this is representing angle theta about which this vector is rotated. If vector is rotated, its magnitude remains same, which is given in the question, that is L. L is the magnitude of the vector. Suppose initially it is representing xi vector and finally it is representing xf vector. I have used different because direction of vector changes, therefore vector will change, but its magnitude remains same, means magnitude of xi vector will be equal to magnitude of xf vector, which is equal to L given in the question. Now we have to find what is the change in position of its head. Initially head is here, and now after rotating the vector, head reaches to this point. So this is representing change in position of its head. So we have to find this vector. Suppose it is represented with the help of delta x. Delta is representation of change and x is the representation of position. So this is representing change in position of head of vector. Initially vector is xi, after rotating it becomes xf vector, and delta x is representing, that is vector of change in position of its head. We have to calculate that one. That means we have to find delta x vector. Now with the help of vector law of addition, we can see xi vector plus delta x vector, because these two vectors are in same order, that is head of xi vector coincide with tail of delta x vector. Therefore we can say xi vector and delta x vector are in same order, or we can write xi vector plus delta x vector, because they are in same order, will be equal to xf vector, because xf vector is in opposite order as that of xi vector and delta x vector. Therefore on rearranging this one, we will get delta x equal to xf vector minus xi vector, and we have to find delta x vector, which can be seen it is the difference of two vectors, that is xf vector and minus xi vector, and we have to find its magnitude, that is magnitude of vector difference of two vectors, and we have already seen these two vectors are equal in magnitude. Now we will use property of vector subtraction, that is if two vectors, if suppose vector A and B are such that their magnitudes are equal, then A minus B whole magnitude can be written as 2 times of A sine theta by 2, where theta is the angle between A vector and B vector. We will use this conclusion for solving this question, and we can write delta x vector whole magnitude, which is equal to xf vector minus xi vector, can be equal to 2 times of magnitude of either of these vectors multiply by sine of angle between them. Angle is theta and we have to use half angle, therefore it can be written as 2L sine theta by 2, because magnitude of the vector is L. Therefore we have to find the change in position of its head, which is coming out 2L sine theta by 2. Therefore answer of this question is 2L sine theta by 2. Thank you.